Good morning, folks. I'm Shahid Aziz. Inspired by Conrad Wolfram's video that we watched in our class last time, I have decided to demonstrate in my Mathcast video how to use computer to teach math in the classrooms. The question I'm going to solve for this demonstration is the first question in our sheet of the week for week 5. The question is about finding a sequence of digits from 1 to 9 using each digit exactly once to result in a total of 7. As you can see, the digits are arranged in two fractions and the sum of two fractions has to be exactly 7. I'm sure there are a number of ways to solve this problem. One of the ways is to use mental math and reasoning, which I tried first, but realizing that it's going to take a while, I decided to use computer to solve this problem. And the first thing I tried on the computer was Google search. You go to Google and copy paste the pattern and click on the first link, and there you go. The very first link opens a page which has a step-by-step explanation of the solution, and if you scroll down you will find the answer. However, this is not how I was going to demonstrate solving the problem, because the problem on this web page is solved using mental math and logical reasoning, and also because what if we don't find the answer on the Google? Of course we can solve the problem using mental math and logical reasoning. It may take a little while, but we should be able to solve it. However, there is another efficient way of solving this kind of problems, and that is using programming language and computers. So here is my program. It's written in Python scripting language, and I have used integrated development environment from NetBeans. And both of these are my personal choices. We can use some other language and some other development environment, doesn't matter. So let's look at the program. The first few lines are in magenta, pink. These are comments. Anything that starts with the hash symbol is considered a comment and is ignored by Python compiler. So the first statement is actually import iter tools, which import the existing library to generate permutations in the program. The next statement is a print statement, just to display a message start of program to show that program is running and is doing something. After that, we are declaring a variable dList and storing the digits 1 to 9 in the list. These digits are stored as characters, not as numeric values, because I want to concatenate or join them lexically, meaning I want to make 1 and 2, the first two elements joined together to make it 12, not to be added as 3. So that's why they are stored as characters, not as numeric values. In the next statement, we're passing the list of 9 elements to a method permutations to generate all possible permutations, and we're storing those permutations in the variable perms. After that, we have a for loop in which the variable p is taking one permutation at a time from the list of all permutations, and we're using the first two elements of the permutation and we're converting them into a numeric value, and then next 3 elements are combined together and converted into a decimal value, and so on. And then the sum of two fractions is stored in the total. The next statement compares the total with 7, and if they are equal, then printing the permutation and the total. So let's run this program. And there you go. We have found the sequence which will result in 7. And the benefit of using computer to find the sequence is that you can find the sequences. Once you write the program, you can find the sequences for other digits as well. For example, if we change the 7 to 4 and run the program again, we will find the sequences that will produce 4. So in this case, there are 3 of them. We can use even some other numbers like 3. Not only we can change the result and find different sequences, we can change the sequence itself. We can change the list, and we can vary a lot of things. This problem relates to the number strand in grade 7 and up.